Welcome you all to EPG Pathshala course on research methodology. I am Dr. K. Ramya, Assistant Professor from Avnashlingam School of Management Technology, Avnashlingam Institute for Home Science and Higher Education for Women, Coimbatore. In this module, we will discuss on non-parametric test part 1. Going to the introduction, we are aware that parametric test has certain assumptions about one or more parameters of the population distribution from which the sample is drawn. Parametric test assumes that population data are normally distributed and is defined by its parameters such as mean and standard deviation. But in real world scenario, we come across data that does not follow any set distribution. To analyze such data, we use non-parametric test which can be used for non-normal variables. Non-parametric statistics refer to a statistical method wherein the data does not have normal distribution. These tests are also called as distribution free tests because they don't assume any distribution. Non-parametric test can be used under the following circumstances. That is, when variables are distribution free and the data may not be put into metric form appropriately and the data may be rank ordered, data may be from small samples, and there may be non-normal distribution of the variables, that is skewed data, and also outliers may be present. The equivalent non-parametric test for various parametric tests are discussed below. Now, considering the one sample t-test, the binomial test and sign test for one median is the equivalent for one sample t-test. Coming down, going to two sample t-test, and in case of paired t-test parametric, the equivalent is the signed rank test, Wilcoxon signed rank test, sign test and McNormet test. In case of unpaired t-test, the Mann-Whitney t-test is the equivalent non-parametric. Now, moving on to K sample, that is N sample. Regarding the equivalent for one-way ANOVA is Kruskal-Wallis test and Conker test. And considering the two-way ANOVA, the equivalent test is Friedman test and Cochrane Q test. Now, moving on to correlation, the equivalent non-parametric for Pearson correlation is Spearman correlation. Now, let us move on to the non-parametric test, which is the topic of this module. The list of non-parametric tests discussed in this session are Mann-Whitney U test, Wilcoxon test, Kruskal-Wallis test and Friedman test. Now, talking about mean ranks, it is a method of handling data which has the same observed frequency occurring at two or more consecutive ranks, and it consists of assigning the average of the ranks as the rank for the common frequency. The first test we are going to see is Mann-Whitney U test. This is a non-parametric alternative test to the independent sample t-test. It is used to compare two sample means that come from the same population, and it is used to test whether two sample means are equal or not. Let us consider the example. Imagine that a researcher wants to know the difference between the effects of two fertilizer on yield of a plant, and if data is not normal, we use Mann-Whitney U test. This is the formula for Mann-Whitney U test. Now, regarding the conditions or assumption for this test, the sample drawn from the population should be random and there should be independence within the sample and mutual independence is assumed. That means that an observation belonging to one group cannot be found in another group. Also, ordinal measurement scale is another assumption. The data requirement for this test is ordinal and numerical data for the variable to be tested. Now, the procedure for doing this test using SPSS: from the menu, choose Analyze, Non-Parametric Test, Legacy Dialogues to Independent Sample t-test. Select the test variable, that is with numerical scale, and then select grouping variable, that is in a categorical scale, and define the groups. Then select the test type as Mann-Whitney U test and click OK. Let us now practically see Mann-Whitney U test using SPSS. Imagine that a researcher wants to determine the difference between the effect of drug A and drug B administered on patients suffering from cancer during the 6th week of treatment. Therefore, the dependent variable is cancer condition and the independent variable is drug, which is split into two groups, drug A and drug B. Here, cancer condition is the test variable and the drugs is the grouping variable. The research question for this test would be, is there a significant mean difference between the effect of drug A and drug B? The null hypothesis is there is no significant mean difference between the effect of drug A and drug B. The data sheet given below consists of responses of 20 respondents. The data includes name, drug type, age group, weights in pound, cancer stage, that is initial condition, cancer condition after 2 weeks, cancer condition after 4 weeks and after 6 weeks. This data set will be used for our analysis. Now let us move into using this test with SPSS practically. Let us use the sample file non-parametric test.sav, which includes the data as given above. From the menu, choose Analyze, go to non-parametric test, Legacy dialogs, 2 independent sample test. Select the test variable as condition after 6 weeks and select the grouping variable as drugs, and when prompted define the groups as 1 and 2 because we have defined drug A as 1 and drug B as 2. In the test type, check if Mann-Whitney U-test is selected. Then click OK. The results will be displayed in the output screen of SPSS, which is as follows. Moving on to the inference part, the ranks table provide information regarding the output of the actual Mann-Whitney U-test. It shows mean rank and sum of ranks for the two groups tested. In the ranks table, it is observed that the difference between the mean ranks between the two groups is negligible, that is 0.62. The next table, that is the test statistics table, provides the U statistic as well as the asymptotic significance p-value. From the table, it can be inferred that the significance is low as the p-value is greater than 0.05. Therefore, we can accept the null hypothesis and conclude that there is no significant mean difference between the effect of drug A and drug B on cancer condition after 6 weeks. Next, let us move on to Wilcoxon test. The Wilcoxon test or Wilcoxon signed rank test is a non-parametric test used to compare two related samples or matched samples to assess whether their population mean ranks differ. It can be used as an alternative to the paired t-test when the population cannot be assumed to be normally distributed. For an example, a researcher wants to know the difference in yield of a plant at the end of first month and second month after treated with fertilizer. And here we have the formula for this Wilcoxon test. Moving on to conditions or assumptions, it is assumed that the two samples need to be dependent observations of the cases. The Wilcoxon sign test assesses for differences between a before and after measurement, while accounting for individual differences in the baseline. The data is assumed to be numerical in nature. The data required for this test is numerical data for the variables to be tested. Regarding the procedure using SPSS, from the menu, choose Analyze, Non-Parametric Test, Legacy Dialogs, two related samples, and select the test pairs which have to be tested. Select the test type as Wilcoxon, then click OK. Let us now practically see Wilcoxon test using SPSS, and we will be using the same data file. A research team wants to test whether there is any difference between the condition of cancer patients at the end of second week and at the end of fourth week after taking drugs. The research question would be, is there a significant difference between the condition of cancer patients at the end of second week and at the end of fourth week after taking drugs? The null hypothesis would be, there is no significant difference between the condition of cancer patients at the end of second week and at the end of fourth week. Now, let us move on to the analysis. with the help of the sample file non-parametric test.sav. From the menu, go to Analyze, Non-Parametric Test, Legacy Dialogs to Related Sample. Select the test pass, variable 1 as condition after second week and variable 2 as condition after fourth week, and then select test type as Wilcoxon. Then click OK. The result will be displayed in the output screen of SPSS, which is as follows. Output and inference. The ranks table provide some interesting data and the comparison of the condition of cancer patient in second week and condition of cancer patient in fourth week after taking drugs. We can see from the table that 17 patients cancer condition had an improvement, whereas 3 patients cancer condition got deteriorated after taking drugs, and 6 patients cancer condition remained the same both in the second week and fourth week. Now, by examining the final test statistics table, we can discover whether these changes due to drugs led overall to a statistically significant difference in cancer condition of the patients. The asymmetric significant value is found to be statistically significant, that is, the p-value is less than 0.05. Therefore, it can be concluded that there is significant difference between the condition of cancer patients at the end of second week and at the end of fourth week after taking drugs. Therefore, the null hypothesis could be rejected. Let us move on to the third test for discussion in this module, that is the Kruskal-Wallis test. This test is a non-parametric test and is used when the assumptions of one-way ANOVA are not met. Both the Kruskal-Wallis test and one-way ANOVA assess for significant differences on a continuous dependent variable by a categorical independent variable. In the ANOVA, we assume that the dependent variable is normally distributed and there is approximately equal variances on the scores across group. However, when using Kruskal-Wallis test, we do not have to make any of these assumptions. Therefore, the Kruskal-Wallis test can be used for both continuous and ordinal level dependent variables. However, like most non-parametric tests, the Kruskal-Wallis test is not as powerful as ANOVA. Moving on to example, a research team wants to test whether there is any difference in yield of plant based on seed varieties. And you can see the formula here for Kruskal-Wallis test. The conditions to be satisfied before applying this test are: samples should be drawn from the population, should be random, and we also assume that the observations are independent of each other. Further, the measurement scale for the dependent variable should be at least ordinal. The data required are ordinal scale, ratio scale, or interval scale variables can be used. Now the procedure for this test using SPSS. From the menu, choose Analyze, Non-Parametric Test, Legacy Dialogs, K-independent sample. Select the test variable and select the grouping variable. Define the grouping variable, then select test type as Kruskal-Wallis test. Then click OK. Let us now practice Kruskal-Wallis test using SPSS. A research team wants to test whether there is any difference in cancer condition of patients after the 6th week based on their cancer stages. We have considered 4 stages in our sample data. The research question is there any difference in cancer condition of patients after the 6th week based on their cancer stages? The null hypothesis is there is no significant difference in cancer condition of patients after 6 weeks based on cancer stages. Let us now use the sample file non-parametric test.sav. From the menu, go to Analyze, Non-Parametric Test, Legacy Dialogs, K-independent samples. Select the test variable as condition after 6 weeks, grouping variable as stage, define the grouping range, that is here 1 to 4, and select the test type Kruskal-Wallis H. Then click OK. The result will be displayed in the output screen of SPSS, which is as follows. The inference is as follows. The rank table shows that there is difference in mean ranks of cancer condition of patients after 6 weeks based on their cancer stages. Mean rank of patients in third stage is higher and lowest in first stage. A Kruskal's test showed that there was statistically significant difference in cancer condition of patients after 6 weeks based on cancer stages. The chi-square value of 10.765 is found to be significant as the p-value is less than 0.05. Therefore, it can be inferred that null hypothesis is rejected, which means that there is significant difference in cancer condition of patients after 6 weeks based on the cancer stages. The last test for discussion in this module is Friedman test. Friedman's test is a non-parametric test for finding differences in treatments across multiple attempts. Basically, it is used in place of the two-way ANOVA test when you don't know the distribution of your data. The example is, if a researcher is interested to test if there is any difference in the yield of plant based on various seed varieties, we can use Friedman's test. You can see the formula for the Friedman's test here. The conditions to be satisfied are, we assume that the sample drawn from the population are random and the data should be ordinal or continuous. Data comes from a single group measured on at least 3 different occasions. The sample was created with a random sampling method. Blocks are mutually independent and the observations are ranked within blocks with no ties. Data requirement, the data should be ordinal or continuous. The procedure for this test using SPSS, from the menu choose Analyze, Non-Parametric Test, Legacy Dialogues, K-Related Sample and select the test variables, then select test type as Friedman test and then click OK. Let us practice Friedman test using SPSS. A research team wants to test whether there is any difference in the 4 groups of cancer condition, that is initial condition, condition after 2 weeks, condition after 4 weeks and condition after 6 weeks. The research question to be framed as, is there any difference in the 4 groups of cancer condition? Moving to the hypothesis, the null hypothesis is there is no significant difference in the 4 groups of cancer condition, that is initial, condition after 2 weeks, condition after 4 weeks and condition after 6 weeks. Let us now use the sample file non-parametric test.sav. Go to Analyze, Non-Parametric Test, Legacy Dialogues, K-Related Sample. Select the test variable as initial condition, condition after 2 weeks, condition after 4 weeks and condition after 6 weeks and select the test type as Friedman. Then click OK. The result will be displayed in the output screen of SPSS, which is as follows. The ranks table shows the mean rank for each of the related groups. The Friedman test compares the mean rank between the related groups and indicates how the groups differed. Mean rank of cancer at initial condition is 1.42 and after 2 weeks is 2.40, after 4 weeks is 3.29 and condition after 6 weeks is 2.88. Based on the observed mean ranks of the groups, it can be inferred that there is difference among the groups. The test statistics table informs the actual result of the Friedman test and whether there is significant difference between the mean rank of related groups. From our example, we can see that the p-value of chi-square statistics was found to be statistically significant at the 5% level. Therefore, H0 is rejected, which means that there is significant difference in the 4 groups of cancer condition, that is initial, condition after 2 weeks, after 4 weeks and after 6 weeks. Conclusion: we have seen that non-parametric tests are applicable when data are not normally distributed. However, non-parametric tests can be applied when data are both normal and non-normal. There are certain non-parametric tests which examines difference in means such as Mann-Whitney test, Kruskal's test, Wilcoxon sign rank test and Friedman test. Certain other non-parametric tests is used to examine the difference in median, such as sign test, McNamara test, Cochrane Q test and others, which would be discussed in part 2 of non-parametric test. We have discussed the non-parametric test based on means in this module. Non-parametric tests are advantageous for the reasons that assumptions on population is immaterial and not much statistical knowledge is required. Further, the test results are not affected by outliers as they rely on sign or mean ranks, and it can also be used for small or large sample. However, non-parametric tests lack importance among researchers for the following reasons. The results do not convey much about actual differences in a population as it is distribution free. In case of large sample, computations are very complicated and it's practically difficult to do modeling using multiple regression. Therefore, researchers shall be cautious before using non-parametric tests as they have less statistical power when compared to parametric tests. They need to apply these tests only when the situation demands the use of the non-parametric test. Thank you all. Happy learning.